We've all dreamed about it. Going back in time to fix a mistake, jumping forward to see the future, reliving a perfect day, or preventing a tragedy. Time travel isn't just science fiction, it's a longing buried deep in human nature, the desire to control something that, for now, controls us. But what if I told you that, according to modern physics, time travel isn't impossible? That the laws of the universe don't forbid it, they just make it unimaginably difficult. Today on the Mind Metrics, we'll journey through black holes, wormholes, Einstein's equations, and quantum mysteries to uncover whether traveling through time could ever become a reality, and what terrifying consequences it might unleash if it did. The nature of time. Before we can bend time, we have to understand what it really is. We experience time as a straight line, past, present, future. It flows in one direction, constant and unstoppable. But science tells a very different story. Time, according to Einstein, is not separate from space. It's part of a vast fabric called space-time, a four-dimensional structure that bends, stretches, and twists depending on mass and gravity. This was a revolutionary idea. It meant that time is not fixed, it's relative. The faster you move, the slower time flows for you. It's not just theory, it's been proven. Astronauts on the International Space Station age ever so slightly slower than people on Earth because they're moving at higher speeds. That's called time dilation, and it means we're already time travelers, just by an infinitesimal amount. But if we can slow time, could we ever reverse it? The Einstein Revolution. In 1905, Albert Einstein published his special theory of relativity, the key that unlocked the modern understanding of time. He discovered that the speed of light, about 300,000 kilometers per second, is the ultimate cosmic speed limit. Nothing can move faster than it, but as you approach that speed, time itself slows down. Imagine traveling in a spaceship at 99.999% the speed of light. For you, only 1 year might pass. But for those left on Earth, decades or even centuries could go by. This isn't imagination, it's physics. It's called the twin paradox. If one twin travels near light speed and returns, they'll find their sibling decades older. That means time travel to the future is absolutely possible. In fact, it's already happening in microseconds aboard orbiting satellites. But what about the past? That's where the real mystery begins. The arrow of time. To move backward through time, we must confront something called the arrow of time. The idea that time only flows in one direction. Why? Because of a law called entropy, the tendency of the universe to move from order to disorder. Eggs break, glass shatters, stars burn out. But they never spontaneously unbreak, unshatter, or reignite. Entropy defines time's direction. Forward. If we could reverse it, we could reverse cause and effect itself. Physicists have tried to find loopholes, equations that allow time to loop back on itself. And surprisingly, Einstein's math does allow it, in theory. That's where the concept of wormholes comes in. The wormhole possibility. Wormholes are shortcuts through space-time, tunnels connecting distant points in the universe, or even different times. They're predicted by Einstein's equations, though none have been proven to exist. Imagine space-time as a sheet of paper. If you fold it and punch a hole through both layers, you can travel from one point to another instantly. That's a wormhole, a bridge through the cosmic fabric. The problem? They would collapse the instant they form. The only way to keep them open would be using a substance called exotic matter, something with negative energy density, capable of resisting gravity's pull. Exotic matter has been theorized, even detected in quantum experiments, but only in microscopic amounts. If we could ever stabilize a wormhole big enough for a human, we might step through one side in the year 3000 and emerge in the year 1200. It sounds impossible, but so did flight, space travel, and quantum mechanics, until we made them real. The black hole paradox. Black holes, regions where gravity is so strong that not even light can escape, might hold the secret to time travel. Einstein's equations suggest that near the edge of a black hole, the event horizon, time slows dramatically. A single minute near a black hole could equal years or even centuries elsewhere. This isn't science fiction. It's observable physics. We've detected gravitational time dilation near massive celestial bodies. Now imagine orbiting a supermassive black hole safely, like in the film Interstellar. A few hours there could equal decades on Earth. That's one-way time travel into the future, but falling in, that's a different story. Inside a black hole, space and time switch roles. Time pulls you inward, and escape becomes impossible. Some physicists believe black holes may even connect to other universes, creating natural wormholes, Einstein bridges. If true, a black hole might not just destroy you, it might rewrite when you exist. The grandfather paradox. Even if time travel to the past became possible, logic itself would rebel. Imagine you go back in time and prevent your grandparents from meeting. That would erase your existence, meaning you could never have gone back in the first place. That's called the grandfather paradox. It's one of the greatest puzzles in theoretical physics. If the past can be changed, how does the universe handle contradictions? Some theories say it simply can't. The Novikov self-consistency principle proposes that events in space-time are fixed. Anything you do in the past was always meant to happen. You can participate in history, but not alter it. Others believe in branching timelines, the idea that every decision creates a new universe. Go back and change something, and you don't rewrite your timeline. You create a new one. That means there could be infinite versions of you, each living in slightly different realities, shaped by every possible choice. And somewhere, maybe one of them already found a way to break the limits of time. Time travel in quantum reality. At the quantum level, time becomes even stranger. Particles can exist in multiple places at once, or even affect each other instantaneously across vast distances, a phenomenon Einstein called spooky action at a distance. Quantum mechanics doesn't treat time as a constant flow. Instead, it's probabilistic, fuzzy, flexible, unpredictable. Some experiments even show particles that appear to influence their own past states. In quantum terms, tiny fragments of time travel already occur in nature. Physicist David Deutsch believes that quantum mechanics could allow information, and perhaps matter, to move backward in time without creating paradoxes. It would simply move between parallel timelines, each with its own version of events. If that's true, the universe might already contain travelers, not moving through space, but through probability itself. The technological hurdle. Let's assume for a moment that the math checks out, that wormholes, black holes, and quantum loops make time travel theoretically possible. The next problem is power. To bend space-time enough to move through it, we'd need unimaginable energy, on the scale of entire stars. To build a stable wormhole would require negative energy equal to billions of nuclear bombs. And even if we had that power, we'd face catastrophic risk. Time travel could tear space-time itself, creating feedback loops or black hole-like singularities that could destroy reality as we know it. It's possible the universe protects itself from paradoxes, a concept physicists call the chronology protection conjecture. In short, nature might simply prevent time travel from ever being possible. But that hasn't stopped humans from trying to imagine how to break the rules. Experiments in time. Over the years, scientists have conducted experiments that flirt with time manipulation. At CERN, particles inside the Large Hadron Collider are accelerated to near light speed, where they experience measurable time dilation. Muon particles, which normally decay in microseconds, survive much longer under these conditions. In 2018, researchers at the Moscow Institute of Physics and Technology simulated a quantum rewind, making a small system of particles revert to a previous state. It lasted less than a billionth of a second, but it happened. Time reversal, not fiction, but function. We're nowhere near sending humans back to yesterday, but these experiments prove something profound. Time isn't as rigid as we think. The emotional side of time travel. Beyond the math, there's another reason we're obsessed with time travel. Emotion. It's about regret. It's about loss. It's about wanting to say one more word to someone who's gone. Every culture's idea of the afterlife is, in a way, a form of time travel, reconnecting with moments we've lost. When we imagine stepping through time, what we really want isn't power, it's peace. A chance to fix, to relive, to remember. Maybe that's why the concept of time travel feels so human. It mirrors our deepest desires and our greatest fears. The future of time. So, is time travel possible? According to Einstein, yes, but only forward. According to quantum physics, maybe, but only for particles. And according to our hearts, absolutely, because we already travel through time every day, 1 second at a time, carrying the past with us. The truth might be that time travel doesn't mean escaping time, but understanding it. And as our technology advances, as we learn to manipulate energy, gravity, and quantum reality, maybe one day we'll do more than imagine. Maybe we'll step across time's threshold and look back at the moment it all began. But when that day comes, one question will remain. If you could travel anywhere in time, would you? So what do you think? Is time travel science, fantasy, or both? Could the next great discovery already be hidden inside our universe? Or inside our own minds? Let us know your theory in the comments. If you enjoyed this journey through physics, paradoxes, and possibility, make sure to like, subscribe, and ring the bell. Because here on the Mind Metrics, we explore the mysteries that define reality itself. Stay curious, because the future might be closer than you think.